Good morning, and thank you for joining us for our talk on Pwncat, which is a tool for automating Linux red team operations. My name is Caleb Stewart, and during my day job, I'm a lieutenant in the U.S. Coast Guard. I'm currently assigned to U.S. Cybercom. In my free time, my off time, I'm a CTF player and developer, and I'm an open source contributor.
Hey everyone, my name is John Hammond. In my day job during the work hours that I have to put up with, I work as a cyber training developer and a cybersecurity content creator. I also like to do a little bit of red teaming on the side. For fun, in the nighttime hours, I like to play capture the flag, and I also like to develop and create some challenges, host a couple competitions. I also have a YouTube channel where I like to create videos and walkthroughs and guides for cybersecurity and capture the flag write-ups. Okay, so our talk, what we're going to be talking about today, we mentioned Pwncat. What the heck is Pwncat, right? So this is a slide, the obligatory introduction that goes over our agenda, the roadmap, the outline of what we're going to be discussing. So what is Pwncat, right? It's a project, and we'll dive into more later, but why do we do this? Why do we go ahead and create this thing? Get a little bit in the rationale, the mindset behind it. And what can Pwncat do, right? So it's a tool, it's a utility. What are all the features and the functionality of Pwncat, and how does it work? We want to do a little bit of a deep dive, go into some of the code, visit the back end in Python as to what this is all written in and why and how, and who cares, right? Where is this useful? Why is this useful? We want to showcase some examples or at least discuss some of them, and we want to talk about what more could we do with it, what else could be implemented, and what we could do in the future. So that's that. Let's get into it.
So now we can kind of now we got that out of the way, we can kind of get into what is Pwncat? What is it used for? Why do we have it? So Pwncat is actually a command and control framework for after you get that initial access. So it takes what you would normally have as a basic bind or reverse shell, and it kind of elevates that into something more on the line with a command and control framework. So it takes where you would normally either connect to or receive a connection from a bind or reverse shell. It will do that for you instead of Netcat, and then it will give you a platform to do more things, to kind of ease your path along those common things that you will do, and maybe in some cases be able to automate some of those things that you would normally do. Pwncat is also agentless, and what we mean by that is that instead of something like, for example, Meterpreter or something like that, that maybe will upload an agent onto that machine that communicates back over specific protocols, Pwncat doesn't have that. Pwncat uses the shell that is running over that raw connection, whether it be Netcat, bind, or reverse shell, and issues commands on that shell across the network. So it doesn't need any type of agent.
So why do we do this, right? Why do we put this together? Well, a lot of reasons, but kind of first and foremost, we're talking about what we've been doing, right? Red teaming, kind of adversary emulation, pen testy stuff. You get a initial access to a machine, your target, your victim, whatever you want to call it, and you do that with a basic bind shell or reverse shell. And when you do that, you get your connection, you get your call back. That kind of sucks. You probably know you've interacted with a couple of reverse shells. Maybe you're interacting with, you got your Netcat connection, and you're trying to tab complete to cat out some of the files in the file system. And you can't tab complete. Maybe you try and move back in your command there, you edit into your command prompt and you're using your left and right arrow keys to move around, and it just sends horrible, gross terminal escape characters and sequences, and that just ruins it. So you try to clear out your prompt and you hit Control-C, and that completely kills your shell. So that sucks. It's not a stable shell. So we wanted to put something together that would automatically give you a stable shell. I put together some cheesy, stupid thing back in the past, my poor man's pen test framework, and I had given a talk on that sort of thing where I would automate kind of the connection, getting it set up, but we don't have the functionality when we do that because I'm automating keystrokes and just doing a dummy way to kind of simulate it. We aren't actually getting a scripting or automation and automated interaction on the target. But with Pwncat, we do. And that just changes the game. That's super duper cool.
So now we kind of want to look at how we're using Pwncat. How does it look when we actually type it into a shell? So Pwncat, as John mentioned briefly earlier, is a Python module that you can install. It provides an actual entry point script called Pwncat, and you can invoke it in a few different ways. So we've already mentioned a bind or reverse shell application to Pwncat. So those are shown here as the connect and the listen modes of Pwncat. So connect, you would connect to a remote bind shell, or listen, where you will actually listen for an incoming reverse shell. In those modes, they act a lot like netcat on a really basic sense, in that as soon as you run that, whether if it's a bind shell you're connecting to, you will get presented with a shell, a prompt on the remote machine. Or if it's a reverse shell you're listening for, it will wait and listen for a connection, and once you get a connection, it will give you a shell in that machine. The two other ways we have listed here to use Pwncat are kind of interesting spin-off ways that we added later that were really cool. So one of them being SSH. So Pwncat can use the paramiko module in Python to actually create or actually instantiate SSH connections to a remote host. Say you know the password, or you've somehow gotten your hands on a private key for a user on a remote host. You can actually use Pwncat to establish a Pwncat session over an encrypted SSH tunnel, which is a super cool and super useful thing to do. The other thing that Pwncat is able to do is it, as we'll discuss later, is able to keep track of persistence methods that you might have installed. So if you have that kept track of, you've already connected to a specific host before, you can tell Pwncat, hey, I want to reconnect to this host, and give it an IP address or a host identifier, and it will then look up in its database and say, oh, I have a persistence method for that host as this user, I'm going to connect with that, and actually open another session again with Pwncat to that host, however it knows how. So once you're connected, the initial output, you'll see it does a few different things. Here is an example of listening for a reverse shell, and we see it say, hey, I got a connection from this IP address. So you know where that connection's coming from. You know it's the right host, the one you were expecting. Then we see that it calculates and says, hey, I've never seen this host before. It's not in my database. So it calculates a unique host identifier, or we call a host hash within Pwncat. That's calculated from a few different unique identifiers within Pwncat, or within the remote host, including things like the host name or interface MAC addresses, things like that. That will be unique even if, say, you're behind a NAT. So the IP address might be the same for multiple hosts on that network for you. Then it tells you, hey, I know that I can see that I'm running in this shell, in this case bash, and then it'll tell you, hey, I'm ready. Here's your shell. So that at that point, you have a shell. This is just a basic bash shell on the remote host. This shell, though, while it is just a basic shell, is already set up right off the bat for it to be stable. Pwncat has already figured out this is how I need to start a PTY. I'm going to start that PTY. I'm going to unset history file, make sure all of that is all set up for you, and then give you the shell. At this point, you can use your arrow keys. You have command history within this session. Like I said, it disables it for saving that later. And you also have things like graphical programs, or at least terminal graphical applications, things like Vim and Nano and things like that will just work. It synchronizes the size of the terminal, synchronize the type of the terminal, all those types of things will just work right off the bat at this point. The more interesting things that John mentioned earlier about scripting and doing things like that, that all comes through the local Pwncat terminal, which you can get to by pressing Control-D. So at any point when you're just at a regular terminal prompt, you can press Control-D and Pwncat will say, hey, we restored your local terminal. Here's your local prompt. That's where you're going to be able to start entering some of the interesting automated parts of Pwncat. You'll be able to get into that stuff. Initially, we had used something like SSH does, where in SSH, if you press ~C, you will get a local SSH prompt where you can change your port forwards and things like that at runtime. We had used something like that, but we found it's kind of awkward when you need to do that multiple times or over and over. It's kind of awkward to press. Also, Control-D has the added benefit of not allowing you to accidentally exit your shell. Sometimes I'll come back to a shell on a regular reverse shell maybe that I've stabilized manually, and I'll hit Control-D, not thinking about it, and I've just lost my shell. That might make you think, well, what if I need to send Control-D to the remote process? What if I run some long-running process that I need to send Control-D to exit? So to do that, you can actually, Pwncat has the idea of a prefix key, which you can bind other key shortcuts to later. A default binding is Control-D. So if you press the prefix and then Control-D, you will actually send that Control-D directly to the remote process. So if you need to send Control-D, you can in that way. The Control-K is configurable to different things if you would like it to be later.
And enter the configuration file, right? So As Caleb was mentioning, okay, we're going to talk about that prefix key, kind of like how tmux or Screen has that when you actually want to send keystrokes to the running program that you're working as. In this case, Pwncat will have that exact same setup. By default, we set a prefix key of Control K. That was honestly just because it's like on the other side of the keyboard as opposed to Control D, so it's a little bit more natural with your fingertips and your hands, but that way you won't accidentally kill your shell with the real Control D keystroke, only unless you really, really mean to. You really, really want to. You purposefully want to close that connection. With that, you can use the prefix command and make sure that's going through. We also have the configuration file set up so you can determine specific things that will be used throughout Pwncat. We talked about some of the persistence or the privilege escalation stuff that we do. In ever the case we need to create a backdoor to get our access back, we could set, hey, a configurable variable, let's say the backdoor username or backdoor password. By default, we just set that to Pwncat. And of course, a database that we're going to store stuff in that we'll touch upon later. One of the really, really cool things you can do with this configuration file is that you can specify commands or things that you want to happen immediately once you get that connection. So you can see that syntax here, just in the displayed code. We've got set onload. We will run privesc, tac L, and what that means is we'll look for all those different privilege escalation routes or opportunities, and we'll touch on that more. But the really, really cool power here is that you can specify, you can determine once you get your connection, what's going to automatically happen. Are you going to run some enumeration scripts? Are you going to upload a specific tool or a file that you need? Pwncat will handle that all for you, and you can define that. We also allow you to create some key bindings or aliases or maybe nicknames or shortcuts to other commands. Maybe you say, hey, I want the functionality for just one keystroke. Let me run a remote command or a local command, depending on what prompt I'm in, etc. So that can all be configured within the configuration file that you can give to Pwncat at runtime from the command line. So that's cool.
So the next thing after you have that stable shell is that you are going to want to be able to upload and download files. So you're going to go through and you're saying, well, maybe I want to upload a enumeration script, or maybe I want to upload an exploit script, or maybe I want to download one of those configuration files or some source code to analyze locally. That stuff's really important, but it's normally kind of a pain. You normally either have to open another listener on another port, or start an SMB server, or start an HTTP server. You need to know your IP address from the point of view of the other host, if that even exists. All those things are a bunch of ifs, ands, and buts that you need to figure out before you can even transfer a file. Well, Pwncat makes it really easy. You just have these upload and download commands. Well, on top of the fact that you get local and remote file tab completion with these upload and download commands, it doesn't need another connection. It doesn't need to know what your IP address is. It doesn't need an HTTP server, an SMB server. It is shuttling the data through your already open command and control connections so that more connections don't actually have to open. It does that by literally taking the data and saying, I want to put it in this file, and then that remote process listens for the data, and the data gets sent through. That's kind of akin to if you were to open your script or something and copy it and paste the file and then paste it into your terminal. That would be a really gross way to upload a file, but for Pwncat, it's super easy, and it's great, and it's fast, and it's great.
So not only can we upload and download files, right? But we've got this connection. We've got our initial access on the target, on the remote. How can we keep this, right? How can we maintain that access in case something goes wrong, in case that goes away? So we want to be able to establish persistence on the target. That's a common thing that we kind of want to do in our adversary emulation. So in Pwncat, we create all these different commands that you can run. And what they could do is they could be a specific thing, and it could be bundled with a certain amount of functionality or features. And we created the persist command that will open up all the avenues and routes you could do to run a specific persistence method. And that's why you can see that tac M there, because we're specifying a method that we might install or actually put on the target. And there are a couple ways we can do this, right? There's a lot of different avenues or routes for how we're actually going to accomplish establishing this persistence. In this case, maybe you want to clobber some SSH file authorized keys, or we can put in our own public keys so that, okay, authorized keys will authenticate us when we use a private key to log in with SSH. That's one option, right? There are a lot of others, and we could check out what status do we have for the persistence methods that we've installed. What could we do? We have a couple persistence mechanisms, and we can obviously extend this or add more to it, but maybe we could do a PAM degradation attack, right? So that every single user could log in with one specific password that we specify. Or maybe we could just simply change the password for a user, or go ahead and make something a sudo user or a pseudo user so we could get back to that account if necessary, or even if it's a stupid netcat callback in a bash RC. There are a ton of options, and one of the cool things is that sure, we'll go ahead and install and implement this persistence mechanism, but we also want to be able to cleanly remove it in case, hey, we just want to cover our tracks. We're kind of wiping our fingerprints here. So you can see that syntax down below, persist tac clean, and we can remove everything that Pwncat has automated the process of putting it together for us. And that's one of the really cool things, right? Is that we can specify any of these methods that we want to use, but in the back of our mind, we don't have to care about how it's done. We just want to make sure that it's done. And Pwncat will be able to figure out and actually go ahead and go about that in any way that's necessary. And we'll touch on that more, but for now, no, okay. Conceptually, we've got this abstract idea. Let's implement and install whatever persistence method and mechanism that we want and clean up as necessary.
Okay, now that we're kind of talking at this point about modifying the remote system. We're talking about uploading files, we're talking about adding persistence. All these things make individual small modifications to the remote host. All of those things in the context of red team operations or of doing this type of work, you need to be able to track that information. You need to know, I modified this file, I added these lines, I created this file, so on and so forth. I created this user, whatever it might be. So Tamper does that for you. As Pwncat, in all of the backend things that are happening, as it's creating files or modifying files, it will register these different tampers or these modifications of the remote host. And these tampers could be anything. They could be, as you see on the screen, a modified file, a created file. The actual persistence methods you install are tracked here as well. For the persistence, you can see it says persistence authorized keys. We also, in this case, had installed a PAM backdoor. All of these things are tracked by the tamper module itself, which is accessed through the tamper command. What's cool about that is that you can then revert them. So we talked about cleaning up persistence specifically, but what if you've done a lot of different things with Pwncat? You've done maybe persistence, you've uploaded some files, you've maybe installed a few different things. All of this stuff was tracked by Pwncat, and now you can say, hey, I want to revert it all. I want to go back to what it was before as if none of that happened. It can do that because it's tracked all of those changes and it remembers them in between sessions and it knows, which is super cool and very helpful during an actual operation.
One thing that I kind of got into while I was playing with Pwncat more and interacting with it in different scenarios and different environments is that maybe I wanted to use some commands or do some tricks that I know in my head are really cool and are fun to use, but that specific command or functionality wasn't available on that remote target. Like maybe I wanted to just chatter or use the chatter command, the change attributes and maybe make an immutable bit set on some files because I'm doing some silly tricks. But that remote target doesn't have the chatter binary. Well, I want it, right? So we had this idea, maybe we could actually pull in busybox, which would package with it busybox as a standalone binary with a lot of different commands that could be ran at the shell level, right? As if they are commands, and Pwncat will be able to keep track of them and know that they exist. So we did that, right? Here's the idea. We could automatically determine, here's what the remote system's architecture is, here's what's necessary for it to actually run on the system, and we'll pull down from the internet that necessary package of busybox, set it up so that all the different commands and applets is what busybox will call those commands, for it to actually run those and use those on the target system. Kind of cool, because if we didn't have that command that I wanted to use, suddenly we've got it. And Pwncat will know that it exists, and it'll actually know all of these other commands that maybe busybox brought with it, because all of that functionality is now unlocked by Pwncat. And it could say, hey, if we didn't have that command before, we'll know that it exists, and any other commands that might be necessary, we'll go ahead and use them through busybox because we have proof. We can trust that those commands are now on the box, and we can use those for our advantage doing the live off the land stuff.
So now that we have a stable shell, we're able to upload files, we have persistence, we know we'll be able to get back in. The next step now is to enumerate that remote host. We need to know what's installed, what's there, how can we possibly pivot to something else, all of this information that we just need to enumerate from that machine. So with that in mind, we have the enumerate module, which we are interfaced through the enum command. This command allows us to quickly and easily enumerate a lot of different types of information. It not only presents that information to you in a user interface way, but on the back end that we'll talk about later, it allows you the actual other pieces of Pwncat to reuse that information. It also is stateful in that it knows, hey, I've already done that for this user, or this needs to be done per user, and I haven't for this user yet. And it will do that and won't redo things. If you say, hey, I want to enumerate all this stuff, and then you run it again, it won't go back and run those commands on the remote host again. It'll say, hey, I already know this information, here it is. There's no reason to go back to the host. Another really cool thing that it's able to do is that sometimes when you're enumerating information, some of the output might be really big. It might be super long, it might be hard to read. Maybe you enumerated a bunch of private keys for whatever reason, or you found a private key and you need that. That doesn't really display very well in the terminal, hard to copy out, those types of things. So there's actually a report option to the enum command, and it allows you to generate a report of all the different facts that Pwncat was able to find. And each of those facts could be something as simple like it shows as a sudo capability. It could be a password it thinks it found in a configuration file. It could be the SE Linux status. There's a lot of different enumeration methods that are implemented right now. I mentioned a few of them. Some other things are things like kernel version, versions of different binaries like screen that might be vulnerable, just a ton of things, users and groups and set UID files and executable capabilities. Everything you would expect out of a Linux enumeration script are the things that we've been trying to implement into these enumeration methods. And so that's the goal, is to kind of replace all of those different enumeration scripts with this one simple command that allows you to generate a nice report. And also, on the flip side, reuse that information for automated privilege escalation or persistence and so on and so forth.
So yeah, we mentioned privesc, and that was honestly, in my mind, like one of the coolest things we could do with this. When Caleb was kind of putting this project together and he was fixing some of the bells and whistles to give it more features and make it pretty, I was just kind of off the races because I wanted to let's try and automate an actual privilege escalation technique with just one command, privesc, and it would just do it. I thought that was the coolest thing in the world. So what I wanted to do was I wanted to have let's give Pwncat the ability to survey the scenes and see what's out there. What can you see? Do you have pseudo privileges as this user? Do you see any set UID binaries that you could abuse and kind of reach out to another layer of privilege? Could we run dirty cow, some cheesy kernel exploit? That would take a long time and it's not always effective and applicable. Or maybe we could find some passwords, or there's one of the CVEs for screen. All these different things that we wanted to do. And we thought, let's put it together in a way that Pwncat can find and reach for all the binaries and the things that are on this actual system. It's going to live off the land with the binaries and files that it can find. And it will do that with some capabilities. What can it find that has read access or write access or can grant me a shell? And we'll kind of deep dive on that a little bit more. But I want to drive the point home that Pwncat was able to figure out how to escalate to a specific user. And any user that you wanted to, right? You say, okay, maybe I want root, get me the keys of the kingdom, make me the king, or any other kind of middle, average privilege user, or starting from www data, get me to whatever I want to be. And that was really cool in that it was able to do that. And it's even cooler in that once Pwncat gets from one user to another, maybe we went from user 1 to user 2, and now that we're in user 2, we can see more that user 1 wasn't able to. Maybe he didn't have the read access in some directories that had some set UID binaries, or maybe that user previously didn't have pseudo privileges, but this one does, and it can do something else. So we could move from user to user to user to user and chain these together. And that was super duper cool. It will recursively look for the footholds and the misconfigurations on a user by user basis. And one thing that we notice is while we're maybe trying some of these set UID binaries, if you notice when you do that to get to another account, if you get a shell, you're noticing your effective user ID is what's giving you the privileges of that new user, but it doesn't match your real user ID. So there's an EUID and UID mismatch. Well, sometimes that gets annoying because maybe you can't write to the sudoers file, or you can't put some specific file in some directory. Whatever the case may be, we wanted to account for that mismatch and automatically be able to correct it. So that's where you see those backdoor user comes in. Let's put in maybe a Pwncat user that we can just SU into, or specify a password and authorize keys to reconnect in and get that full user capability, make it my real user ID, not just my effective user ID. And that's something that Pwncat knows how to do. Super duper cool. Just one command, privesc, and now you're root. Very, very cool. The way that we do this, and this is the deep dive, right? This is kind of where we get into some abstract thinking, because we thought about, let's look for those set UID binaries. Let's look for those specific sudo commands we can run. But all those are really, really unique and really, really specific as to how they're actually going to do this technique, or go ahead and perform this method of privilege escalation. So we essentially made our own copy of the gtfobins resource, which I'm sure you guys know is out there. Okay, some of the live off the land binaries and commands you can run in Linux to escalate your privileges. So we'd set up a JSON file, this ginormous JSON file that I poured a lot of time and effort into. You can see like the Sublime Text mini map over on the left-hand side. It's like 3,000 lines. But for as many commands as we could find, we would specify, what can this command do? Can it read a file with some specific syntax, or can it write to a file or get a shell? Do we need to specify some specific arguments to maybe run with set UID privileges? And how is this file going to take in or put out information? Is it going to be like printable characters that are safe to be displayed out on the terminal, ASCII letters, English stuff? Or is it raw bytes, or like raw data that our terminal needs to be in a different mode to be able to read and interpret, like raw mode? Or can we just maybe mask it and hide it within base 64, which gives us a lot more flexibility in the data that we put in? Because, okay, some of those special characters, maybe new lines if it's sensitive or whatever the case may be, don't get clobbered and eaten and completely destroy the state of our terminal because we're trying to automate this. But anyway, all that, the coolest thing is that it doesn't matter how to do something. Let's say you're in the situation, you want to read its set password. Okay, you could do that with cat, or you could do it with grep, or you could do it with more, you could do it with less, or you could do it with awk, you could do it with, and it doesn't matter. Pwncat will be able to determine you want something that has read capability, and that any gtfobin will do if we can find it, if it's on the system. Or you want to write to a specific file. Maybe it doesn't matter how you do it. We'll find one gtfobin that's on the system, live off the land, and you can authoritatively say, just give me this access, and Pwncat will find a way. And that's really, really cool.
So now, as John kind of mentioned, we're kind of stepping into that deep dive side. So we talked about that front end, we talked about how you interface with Pwncat, and now we're kind of getting into how does this work in the back end? Because all of these things we talked about up to now have an easy way to add things to it. The whole point of Pwncat was, hey, I want to be able to have a nice little interface. I want to be able to type download, but also I want to say, hey, there's a new privesc that I think I could automate really easily. Let me go write that real quick in Python. And there it is. It works. So with that in mind, I tried to take this object that we call victim and abstract some of the really common operations you would want to do on the remote host. One of the coolest things that I think, and it kind of blew my mind when I thought I could get this to work, and it was even crazier when it actually did work, was taking the built-in open function in Python, but creating a version of that for the victim object to open a remote file, and not just open it, but return a file-like object in Python that you can interact with like any other file. So here in this little example we have, John mentioned trying to read etsy password, and that's great. You can use victim.gtfo, inner methods, find a gtfobins method on your own, and run that command and read the file. And that's great. That's fantastic that that works. I went one step further, and I implemented an abstraction on top of that. So open will actually use those methods, those gtfobins methods, to open the file and return to you an abstract file-like object that you can simply use .read or .read lines, or iterate over it like you see in this example to get all the lines from the file. And that's it. That's all you have to do. You have the contents of etsy password at that point. And it also supports write as well. You can't do read and write. That doesn't work over one C2 channel. However, you can do read or write in binary or text mode. It all works, all the methods of a normal file like object. There's some other useful file system type abstractions in there. Another example we have here is access. We want to say, hey, do we have read access to the Etsy shadow file? That's useful, right? We want to read everyone's hashes. Other things that access returns, obviously whether or not a file exists, whether or not you have read or write access to the parent directory, that kind of thing. It returns a bunch of useful information about that actual file. There's some other file system abstractions, things like list directory, changing directory, all of those are abstracted within the victim object. So as you're implementing these, whether it be a persistence module, a regular command, a privesc module, an enumeration module, whatever it is, you can just interact with it like it's your local host almost. It's simple. With that, aside from just interacting with the file system, you can interact with processes. So you can say, I want to run this process on the remote host, and I want a pipe that actually gives me read and write access, simultaneous in this case. You can have read and write access to the standard I/O of the remote process. So that's what subprocess will do. It will give you an actual file-like object that you can read and write from. In this case, we're reading a list of groups from the ns-switch getEnt command. The other options you can do are, for example, a run, which is a little bit simpler. It doesn't give you a file-like object. You just get the standard output of the process back after it's finished completing. So that's super useful in some cases. Like, I don't need all those features of a pipe. I just need the output of the command. So that will give you that bare bones command access. And then kind of more abstract as we step away, this is another feature that kind of was amazing. It was super useful and amazing to me once I got it working, was this idea of compiling. So a lot of exploits that we do, you might need to compile actual C code for that remote host. And there's a couple different ways you can do that. Namely, there's mostly only two, right? You're either going to compile that on the remote host if they have a compiler, or you need to use a cross compiler and upload the compiled binary. But you don't want to have to do that logic every single time you implement an exploit that needs a compiled binary. Either it's an exploit, or I've even had to implement a persistence module, for example, that needed to compile a binary. You don't want to have to do that every time. That's an annoying comparison to have to make, and then you have to upload files and download files and so on and so forth. Instead, I abstracted that away. You can now simply run compile, and it will check and see, hey, do I have a compile in the remote system? Yes? Okay, cool. Let me automatically upload these files. Let me compile the binary to a temporary random path on the remote host. Let me clean up any extra files that were created in the process and return to you just the path that new binary is going to be at. Maybe you don't have a compiler in the remote host, but the user maybe set cross, which is an actual configuration item you can set in Pwncat. And that's going to be set to an actual cross compiler that compiles code for the target, for that victim. So that means Pwncat now, instead of even looking for a compiler on the remote host, it's going to say, oh, well, I can compile code for that target directly. So it's going to compile it locally and just upload the compiled binary to that remote host. Another useful thing when you're writing these persistence modules or privesc modules is that this actual compile command can either take file names relative, obviously, to whatever your current directory is. It can also take file-like objects. So maybe you have a string IO object with a short C file just right there. You can send that directly there, and it will work as well. It doesn't care which thing you pass to it. And then also, now that we've kind of talked about the actual victim abstraction, we can move on to the actual enumeration modules. So now that we can adequately abstract the victim, now we can implement better enumeration modules. Instead of having to manually say, oh, do I have cat? Okay, I've got cat. Let me cat this file. Let me see if this exists. All of that type of things that's just going to slow you down implementing these enumeration modules. You can now use those abstractions and implement them. And on top of implementing better enumeration modules, you can use that enumeration data throughout Pwncat. So the enum command is using this victim.enumerate module to abstractly show you those things in a human readable way. But you can also get to the raw data. In this example, we grab kernel exploit data, which is going to go through and say, hey, does this kernel version that we're running on the remote host match any known CVEs for kernel vulnerabilities? If so, let's return the CVE identifier, the name, a link to the implementation, all that useful information. It'll also implement or enumerate all of the pseudo information as well. And that's not just a user readable string, that's actually the raw data, the user, the command that you're allowed to run, the run as user, run as group, any options, hosts, hashes, all of those pieces. It parses out of the pseudoer's information and gives it to you in a usable way.
All right. We've thrown a lot at you, right? So who cares? Why is this useful? Where is this useful? Well, obviously, right, we come up to you and say, your mileage may vary, right? We don't know. We can't promise that this will work in every situation, always, all the time, forever. But we think it's really cool, and we've had a lot of fun with it. We've gone ahead and tested it. We played with it on a few different, honestly, the easiest and most common thing for us to work with are kind of well-known online practice or war game, like cyber range environments and exercises. So Try Hack Me is a fine example. I really love the stuff that they do. So quick shout out to them. But a lot of their exercises, a lot of the machines that they put out, we've been able to explore this and try out Pwncat, try out some of these techniques, privilege escalation, persistence, enumeration, finding passwords, et cetera, and honestly, it is just so cool to see it work, right? So here's just a few examples. We listed out just a couple of their machines or levels and boxes you could play with. Some that are labeled like hard, or their difficulty is set to like intermediate or easy or difficult, whatever the case may be. But it's so cool to just get, once you have your initial access, run privesc, and boom, your root, game over, you've won. Like, that's super duper cool, because it doesn't matter what it is. Hopefully we've got enough of an arsenal and a toolkit and an inventory of these different commands, the gtfobins stuff that you're using to live off the land, and sudo, set UID, maybe some screen CVE, all these different potential privesc techniques or things that we could do. There's just a lot, and it's kind of cool to see it in action. But now what, right? We feel like we've laid the groundwork. We feel like we've got a little bit of a fundamental framework and everything. We've got stuff put together, but there is always more to do. And we've got some crazy ideas, right? We've kind of mentioned Pwncat is all about being able to automate the end target, being able to automate and interact with the victim without ever being even on that machine before. We can script on it any way that we want, and that's crazy cool. That just opens up all the doors. Maybe we could write some specific commands or units or modules that could let us maybe do aggression techniques. If we're playing like a King of the Hill game, maybe spam the terminal or the PTS of every user with like dev random, or run terminal parrot, or wall everyone, or fork bomb. Who cares? Maybe you want to be a little bit more stealthy. Maybe you're using this for some actual op, or who knows? Okay, you could clear log files maybe, or do some like time stop like commands, like clobbering the time stamp and with the touch command on Linux. Maybe hiding files with Unicode homoglyphs or zero width space characters. Who knows? Maybe we could add more to persistence, right? There are a lot of options. We could use that shatter binary to do stuff. We could backdoor crazy things like prompt command or the trap debug, and maybe inject into a driver, or backdoor like apt and git, so many things. And privilege escalation, right? Container escapes with Docker. Maybe you're using that to privesc and LXD, the sudo CVE we saw recently. It'd be awesome to add into our upload and download functionality, being able to transfer and exfiltrate stuff. Maybe add some more protocols, right? We could do that with SMB, we could do that with FTP, maybe even do something with like ping, get ICMP in there. That'd be very, very cool. One idea that we've had that I think honestly sounds awesome, and we tried a little bit of proof of concept with this with like Squid as a proxy, but maybe even use like a SOCKS 5 proxy so that your target, the remote host that you're interacting with, can have internet, even if it's in an environment in a space where it wouldn't otherwise have internet. It doesn't naturally. So, okay, if busybox doesn't give you the commands that you want, you just don't have that functionality already on the system, well, you've got internet. Install whatever you want, and that's crazy cool. Maybe port forward to other machines in a local area network. Who knows? There's just so much we could do with it. Maybe even install some kernel rootkits, right? Put in Reptile or Prism for some crazy cool persistence. There's just so much, and we're really excited about all these ideas, and maybe you might have some really cool ideas too.
So yeah, I mean, at this point, like John mentioned, this is an open source project. Please come contribute, whether it's a pull request or an issue. I always feel kind of awkward submitting issues and no pull request, but honestly, it's fantastic. I've had some people that have just submitted issues and like, hey, I tested it on this machine. It's running these things and it didn't work, or I got this output, and it's incredibly useful. So please, even if all you can offer is it broke, please help. Give me a screenshot. Tell me what you were doing, and we can make it better. So thank you. Please come help out.
All right, we're going to wrap it up. I think we're cutting way into our question and answer time. But hey, we hope you guys love this stuff kind of just as much as we do. If you have any questions for us, if you want to reach out, if you want to contact us, you can find me on GitHub. You can find Caleb on GitHub, Twitter, LinkedIn, email, of course, my Discord and YouTube if you're interested in that sort of thing. But please go check out the GitHub repository. Go check out the documentation. We do this because we love it, and we're here for you. If you have any questions, if you just want to chat, you want to talk with us, we are here for you. That's why we're doing this presentation. That's why we're doing this talk, and we're just so thankful that you guys were wanting to come take a look at it and hang out with us. So that's all. Thank you for tuning in and listening to our talk. We hope you enjoy Pwncat. We love it. And thanks again for coming to our talk, and enjoy the rest of GrimCon. Thanks.
Thanks.